Yo, what's up everyone? Welcome back. Patrick here, and moving on to the next example, we're told that car A and car B start at the same spot. We're told car A starts driving north at a speed of 30 kilometers per hour, and then half hour later, car B starts driving east at 40 kilometers per hour. We have to find an expression for the distance between the two cars in terms of t if we have these two scenarios here. So t represents the number of hours after car B starts driving, and then part B, t represents the number of hours after car A starts driving. Right? So if we show this on a diagram, basically what's happening is, let's say both cars are starting right there. What happens is car A starts driving north. So it's going to start driving north. This here represents car A. And then half hour later, car B starts driving east at 40 kilometers per hour. So car B, half hour later, is going to start driving east this way. Now, if it's starting half hour later, how far has car A driven in half hour? Well, if it's driving at 30 kilometers per hour, it's covering 30 kilometers in 1 hour, then in a half hour, it's already covered 15 kilometers by the time car B starts driving. So if we sort of adjust this diagram for that information, basically up to this point, let's say this here is going to be 15 kilometers, and then car B starts driving east, and then car A continues to drive north, right? Like that. So we have to find an expression for the distance between the two cars. So the distance between the two cars is going to be that. So notice this here is basically going to be a right angle triangle, right? Because it's going north, car B is going east, that's 90 degrees between those two paths right there. So we know that this distance here is going to be the hypotenuse of this right angle triangle. So we know we're probably going to have to use Pythagoras theorem somehow. The question is, how are we going to do that? So notice that this here represents the distance, right? And so what this is going to represent, this has to be a distance as well. Everything has to be in terms of the same unit. So this is going to be a distance, this has to be a distance, and then this has to be a distance as well. So this here is going to be the distance that car B drives. And then this here is going to be the distance car A drives, like that. And so this here, I'm kind of just keeping everything in words right now, is going to be the distance between the cars, right? This distance car A drives, this is the distance car B drives, and then this here is going to be the distance between the cars. And so what we can actually do, I'm going to erase all of this here, is just with those words for now, not even using any variables yet, we can create just a general equation with these words using Pythagoras theorem. So basically we would have, we know a squared plus b squared equals c squared, right? This is like the a, this is like the b, this is like the c, or c squared equals a squared plus b squared. And so what we can say is, let's put the c squared on the left side. So that's the distance between the cars. So what we can say is the distance between the cars squared equals the distance car A drives squared plus the distance car B drives. And then that's going to be squared. Right? So no variables introduced yet, just keeping everything really general for now, but I just want you to understand what is happening over here. And now what we can do is we can start introducing some variables. So part A, we have to make this distance between the cars. So actually one more thing before we get into the variables. We need to isolate for this. So basically we got to square both sides. So if we get the distance between the cars by itself, we're basically going to square root all of that. All right, so the distance between the cars is basically the square root of the distance car A drives squared plus the distance car B drives squared. Okay, so now let's try to get this in terms of a mathematical expression. So in part A, we have to let T equal the number of hours after car B starts driving. T is the number of hours after car B starts driving. Okay, so what's the distance that car A drives? Well, notice that before car B even starts driving, car A, as we mentioned, it already drove a distance of 15 kilometers. And then what's going to happen is car B is going to start driving, and then car A is going to start driving, but from this point over here. So how can we create expressions for this and this over here if T is the number of hours after car B starts driving? Well, we know just in general, what does distance equal? Distance is equal to speed times time. And if we're letting time be the number of hours after car B starts driving, what's the distance that car B drives? Well, it's going to be its speed, which is 40 kilometers per hour, times the number of hours it's driving. So the distance car B drives is actually, we could represent that as 40t. The distance car A drives is driven 15 kilometers here, and then this distance here is going to be 30t. This circled portion here is going to be 30t, because remember, t represents the number of hours after car B starts driving. So let's say 1 hour after car B starts driving, car B's driven 40 kilometers. Car A is driven 15 plus 30 times 1, which is 30. So this total distance is going to be 45. The 15 that it was driving initially, plus 1 hour after car B starts driving, that means from here, car A drove 1 hour, so that would be 30. So basically, the distance car A drives is going to be 15 plus 30t, or not to the power t, what am I saying? 30 times t. That's going to be to the power of 2. Sorry, kind of mixed up right there. 15 plus 30t to the power of 2. So this here represents 15 plus 30t, the distance that car A drives. And remember, t is the number of hours after car B starts driving. And then the distance car B drives is just 40t to the power of 2, like that. Right? And so from here, really what we got to do is just expand and simplify this. So notice that if we FOIL this out, 15 plus 30t times 15 plus 30t, 15 times 15 would give us 225. And then 15 times 30t would give us what? 450t plus 450t. And then 30t times 30t gives us 900t squared. And then this here is going to be 1,600. T squared. And then we just have to collect like terms. 900t squared plus 1600t squared, that would give us 2500t squared. 450t plus 450t, that would give us 900t. And then we got this 225, like that. And so that's the function or the equation for the distance between the two cars if we let t represent the number of hours after car B starts driving. That is the simplified expression right there. Now, what about part B? What if we let T represent the number of hours after car A starts driving? Okay, so this one's going to be a little bit, in my opinion, actually a little bit more complex. Okay, so how is, first off, this general formula is still going to stay the same. The distance between the cars is going to be the distance car A drives squared plus the distance car B drives squared, all square rooted. It's just this portion here is going to be different. Okay, so T now is going to be the number of hours after car A starts driving. Well, actually, the distance car A drives, that expression is actually going to be more simple. It's just going to be 30t. If you think about it, right? The number of hours after car A starts driving, well, in half hour, t would be 0.5. 30 times 0.5 would give us this 15. After an hour, 30 times 1 would be 30, right? Or in 3 hours, 30 times 3, it drove 90 kilometers. So that expression for the distance car A drives is actually going to be more simple. It's just going to be 30t squared. We don't have to worry about adding this 15 at all because it's not the number of hours after car B starts driving. It's the number of hours after car A starts driving. So that 15 is sort of quote-unquote encapsulated within that expression. But now the distance that car B starts driving, this one's going to be a little bit more complex. Now, notice we know distance equals, again, speed times time. So the distance that car B is going to drive is going to be its speed. What's its speed? Its speed is 40. But we're going to have to adjust this over here because this t now represents the number of hours after car A starts driving, but car B starts driving half hour after car A. So what that means, if you think about it, if we have car A, let me kind of show you the pattern here, and then car B, if car A has driven 2 hours, how long has car B driven? 1.5 hours. Because it starts half hour after car A starts. If car A drives 1 hour, then car B has driven 0.5 hours. If car A drives 5 hours, then car B has driven 4.5 hours. So if you think about it, the time car B has driven, the number of hours car B has driven, is always going to be the time car A has driven minus 0.5. Because we're in hours, right? So we're always going to be subtracting 0.5. And the time that car A drove, well, we're just representing that with t. And so this expression represents the number of hours that car B has driven. So that would go over here like that. So this now is the expression for the distance that car B drives. So you can keep it like this. You can also distribute. So you'd have 40t minus 20. Yeah. Right, so that's another way to represent the distance that car B drives. If t is the number of hours after car A starts driving. So if car A has driven 3 hours, we would plug in 3 here. 3 minus 0.5 would give us 2.5. Or if car A has driven 2 hours, plug in 2 here. 2 minus 0.5 gives us 1.5. That would be the number of hours car B drives. And so basically, we would plug in this or this here into this bracket. I feel like this one is easier to plug into. You could plug in this one as well, but you'd have to square then both of these terms. I'm just going to plug in this. This would be 40t minus 20 to the power of 2, like that. All right, so just coming up with this, I feel like is a little bit trickier. That's why it was part B, number of hours after car A starts driving. All right, and then from here, just like we did before, we basically have to expand all of this and just simplify all of the like terms. So this would end up being the square root of 900, or the square root of 900 t squared, right? 30 to the power of 2 is 900, t to the power of 2 is t squared. Then this 40t minus 20 squared, it'll be two brackets, FOIL them out. 40t times 40t gives us 1600 t squared. 40t times negative 20 would give us negative 800 t minus 800 t. And then negative 20 times negative 20 gives us 400, like that. Right, and then just simplifying all of these like terms here, we would end up having 900 t squared plus 1600 t squared would give us 2500 t squared. Minus 800 gives us minus 1600 t, and then we have this plus 400, like that. So that is the answer for part B. That's the expression for the distance between the cars if we let t equal the number of hours after car A starts driving.